So this is one of the rooms where there's like a last minute AV shenanigan. So there's a small echo that I'm hearing that's cognitively disrupting my ability to speak. I will overcome with your help. And the way that you're going to help me is listen to some really bad TypeScript puns, which will help me like get into the, okay, this is how my hearing is going. Why did the string and the number break up? Don't you answer this. I know you know it. Stay here. Because they weren't each other's type. Ah! Okay. Why do Java and C# programmers oftentimes wear suits? Because they've got class. Ooh. Ooh. Thanks. This is helping. I'm feeling a little better about my ability to speak. And one last one. This is just general programming. Is anyone here at Cascadia JS 2022? Good. Weren't you there? How do fish communicate over long distances? Sea mail. Okay. Let's start over. Hi, everyone. Welcome to this talk. Has this ever happened to you? Yes. Thank you. Have you ever had 9 or more different variations of the same button, let's say the primary button, in your website, implemented differently with only some code reuse? And have you seen that each of these components has a differently structured component backing it? And have you seen that not only is the JSX basically the same, but also different between all of these, but also the styling in whatever styling solution you use is also subtly different in weird and wacky different ways. And then when you try to reuse these things, when you try to do the right thing and code reuse, rah, 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 you end up having to use bang importance or whatever equivalents to get over this. The answer is yes. We've all experienced this. But no, we should not do this anymore. It is, what year is this? 2023. Recreating the same button over and over should be out of scope. And yet we keep seeing it in our designs. Why is that? Hello. For the third time, welcome. This is building a design system mid-flight. I'm very excited to talk to you. I realize it's towards the end of the day and there's a Guardian showing after this, so I will be somewhat brief. First, a long slide. Hi, I'm Josh. I'm an open source maintainer. Does anyone here use TypeScript? Thank you. That's a lot of hands. Can I get an audio yes? Yay, cool, thanks. I'm the one with coffee, none of you. So I don't work on TypeScript, but I work on the tooling that lets you lint TypeScript and run prettier on it. So that's very exciting. I used to work on a web platform team where I learned a bunch about design systems, and I also wrote a book learning TypeScript. Everything that you see from me is generally open source. This PowerPoint presentation behind me, shout out PowerPoint, is online on my website. I also tweeted it. And all the images have alt text, all the slides have attributions if you want to go over this later. More excitingly, the plan of attack. Oh no, my clicker, my spacebar. 3 things we're going to cover today, 3 general areas of talk. We're going to talk about the philosophical ideas behind a design system. We're going to talk about the technical implementation of those ideas, and I'll even walk you through a simulation, a little sketch of a design system. And we're going to talk about my favorite part, the organizational issues. Why we can all be perfectly educated design system engineers and still absolutely fail to make any headway in a company. Very exciting. So let's get started. Oh, this clicker. What is a design system? A design system is a collection of shared visuals used across some app or set of applications. Now, these can be as low level as what I call your atomic, what many call atomic values, like shared colors, buttons, typography. And it can be as grandiose and high-reaching as an app or page layout in an app or website. And the reason why we use design systems is because of the original problem statements. We don't want to have to recreate the same thing over and over and over. It's quite annoying and a waste of our time. So people have banded together and created the concept of design systems, and a way to describe them that is quite popular in the industry that I really like is atomic design. Atomic design is the idea of how to split up the components of your design system, or in other words, split up the things that you keep using in your applications into a certain set of areas. And those are split up into atoms, molecules, organisms, templates, and pages in atomic design. And this is a really common, really well-liked methodology because it helps us really visualize and understand how these things build on each other. how we say combine atoms into molecules and molecules into organisms and so on. It's made by someone called Brad Frost, who is a very entertaining person to follow on social media. You need more of that in your life. So we're going to go through those in order, and I'm going to show you some examples from the Codecademy site. Just curious, who here has used Codecademy? Cool. Who here gave a presentation that included Codecademy reference? Thank you, Diana. Woo. So atoms are the fundamental building blocks of your design system. There are different interpretations of how to do this. I don't think I actually use the correct canonical one, but in my line of work, the way I like to do it is two things are atoms. Atoms can be your abstract concepts, like your colors, your fonts, and they can be HTML tags or very low-level granular single components, like your input areas or your paragraphs. So if we, my clickie's gone. If we were to look at colors, you might have, say, 6 colors designed in your website, let's say like a primary blue, a gray light, and so on. You might delineate your headings as different font sizes or general text sizes, or have even a different font or text for your bodies and paragraphs. And you might have different components for your buttons. You might have a normal button and an active button and a disabled button. And I'll talk about this more later, but it's very exciting to be able to describe buttons in language like active or normal or primary, as opposed to buttons like homepage button v3 experiment 4. It's good to have the actual concept of a button delineated before you implement it. So let's look at the Codecademy My Courses page circa like a year and a half when I last worked on it. Does anyone want to, and please do shout this out, folks in this Mantis room. Does anyone want to guess or suggest what are some of the atoms you can see on this page? I'm going to keep making aggressive eye contact until someone shouts something out. Label, accordion, yes! Awesome, thanks. I spare you now. So in the slides, I have a few different suggestions. Colors are one of the atoms. Here we see actually 6 different colors, which is kind of wild to think. A lot of websites are fancy and complex like this one, but they really don't use that many colors, which is the sign of a well-implemented design system, or people who are lazy. We got different types of text. We got menu text, H2 or heading 2, captions, H3, and so on. We got your buttons. Every web page has a button or 5. We got your different icons, which are common ones, and a few more. So that's good stuff. Oh man, that echo's coming back. When you combine atoms together, you get something beautiful. You get molecules. Now, molecules are very clearly delineated as different from atoms. The concept of an atom is something that's very discrete, very granular. In theory, one could describe protons and neutrons and whatever. We're not going to go there. An atom cannot be split. This is technology pre-World War II. The concept of combining atoms, however, lets you create molecules, which are groups of atoms that are intentionally combined together in known good ways. They can be complex, but they're generally not. You might have like a bunch of different inputs put together for some weird use case, but normally it's like 2 or 3 at most. And a few examples of these molecules would be like a form group. So like a label with text, button, and the secondary button, or something like that. You might have a modal dialog. Who here loves modals? That silence was, I liked that one. And then you might have like alerts, like a little banner on top of the page. So on this one, I'm not going to spare you the shout out to the audience. We got menu dropdowns, we got lists of icons, we got little accordions that I would call that a molecule. And there are cases where it can be an atom. And we got little progress of indicators. And what's, I think, kind of nifty here is that when you just look at a web page on its own, you might not really notice things that, oh yeah, I would call that an atom, or I would call that a molecule. But if you work in the web page long enough, if you use different variations of it, if you do different web pages in an app, you'll oftentimes start to see patterns. And these patterns are very reminiscent of how the people who created the app think about things, which is a theme I'm going to keep pressing into you of. Think of things in atomic design, and then the web page will be made in these predictable, easier to implement ways. Good stuff. Oh, and this progress thing is one of my favorites. All right. When you combine molecules together, much like in real life, you can get organisms. The analogy starts to fall apart after this. A group of molecules is similar to how a group of atoms can create a molecule. It becomes something greater than itself. And generally, it's good not to overcomplicate these things, but you can still create interesting groups of them. So common organisms might be like your global header, the header across every page on your website, or most of them. Or like your confirmation zone, which contains like a heading and some text with buttons, and then one of those buttons launches a modal, something like that. And you might have noticed we've seen fewer and fewer of each type as we get higher in complexity. So too with this web page, where we only see like 2 different organisms here, the global header and then this list section thing. I've got a little bit of an advantage here because I helped people implement this in knowing what's an organism. The last 2 things most companies I've seen don't actually end up using, because by the time they've built organisms, it's just so cheap and easy to make pages, there's no need to templatize further. But you can create templates if you've got a lot of different pages. This is very common in like marketing silos where they just need a lot of similar pages. Or a template might be something like a dashboard view, which contains the primary section with a primary list and then a secondary, which is what we saw before. And then on top of templates, you fill those out with data to create pages, where the learner dashboard would be a page implementation of the whatever that thing was template. That is atomic design. That represents decades of thoughts into user research and implementation strategies and agile methodologies. It's a beautiful thing. And again, I highly recommend read more from Brad Frost if you're interested. But what I really care about, what I think is juicy, is thinking in atomic design. So I'm going to give you a few pro tips, a few good steps to try to make sure you're thinking in ways that align to that. First off, start from the bottom. I used to have a GIF of the Drake thing. Start from the bottom, fill out your atoms first. It's really difficult to create pages and templates in a design system manner if you don't have solidified colors, typographies, fonts, and so on. So I'm going to just show off some CSS here. This CSS has, I'm counting, 1, 2, 3, 4 different colors. But half of these colors are basically the same as another color. There's 10, 20, 50, and then 10, 20, 50. And then there's color that's 240, 245, 250. So I would say, no, don't do that. Instead, create in whatever styling solution you're used to some sort of CSS variable, Sass variable, JavaScript variable, whatever, to store those colors and then reuse it. And this seems obvious. This is like, yeah, duh, of course. You've got the reused constant we extract to a variable. That's like day 12 of comp sci. But this is the most immediate win you can make oftentimes when you're implementing a design system mid-play. When you're working on a website that doesn't already do this in CSS because the people implementing it didn't care about CSS, because who cares about CSS? It's not a real programming language, is a really stupid way of thinking, pardon me. So don't do that. Don't do the X thing. Similarly, another foundational comp sci theology, don't re-implement the same thing over and over again. This is the most annoying, the 9 different buttons, the dashboard button, the homepage button. And this shows up a lot in page-specific CSS or components. So again, looking at an example, don't implement like a button checkout, button dashboard, button extra, button flash. This is the wrong way of thinking about things most of the time. Absolutisms are hard. But most of the time, you don't want to think of buttons as specific to a page. You want to think of the page using an existing type of button that exists in your catalog, your design system of components. So instead of these 4 buttons, have 3 buttons, or a certain set of buttons that the page can then use. Have a button primary, a button secondary, a button inverse. And again, this is the same as in regular programming in JavaScript or TypeScript or what have you. Don't create a create menu list for user who is logged in and a create menu list for user who is logged out function if the two do the same thing. Just reuse. Bad. And then another thing, is anyone here familiar with solid principles? You're supposed to, depend on the abstractions, not the implementation details, something like that. Don't hack the internals. So by hacking the internals, I mean, don't use CSS or similar styling techniques that target the inside of a component, because the component should be giving you an API to modify that thing. Instead of having all buttons given a certain padding, and then specifically the checkout page button given a certain thing, and then the dashboard button given a certain thing, instead, just make a different version of the button. And this is really good for 2 things. 2 reasons. One, when you want to update it, you've got one place to update instead of 50 million, one for each page or so on. And the second is that you allow the component to control its own destiny. If you want to update the component where someone else has previously used a bang important to change its styles, you're going to likely cause a bug. Don't cause bugs. Don't do that. And the last one for these tips, build systems collaboratively. I mentioned earlier that you can be the most educated, informed, whatever design systems engineer, and you can still fail to get this working in a company. because you're not the only person likely working in your company. If you're a dev team of one, great. If not, you've got coworkers. So don't do the like kind of traditional waterfall-y way of thinking about implementations. Let's say that your product team decides on a feature, then the product team designs it, then the product team starts the implementation, and then at the very end, do you come in saying, hey, you used hacked internals, or hey, you created a new button. No one is going to want to work with you. And what's going to happen then in that case? Product work is not going to halt because you said that the button was wrong. I have yet to see an organization where that's possible. I've literally seen a giant copy and paste of a design system because someone needed one new feature and then eventually it just kept growing. It was horrible. People might hack the components. They might hack the internals. Or they might just copy and paste the specific components. None of these are good options. So you want to get involved early. You want to collaborate as soon as possible. Instead of the previous thing, when the product team decides on a feature, if you can, get the design systems team or yourself or whoever, someone who knows about the design system practices involved, so that when the product team creates the feature designs, in parallel, you can figure out if there are any new augmentations to your design system you need, and then work that into the time budget for the product team's needs. Ideally, you finish it before they need it. Maybe you work on it alongside them. Either way, everyone is happy because you have built a design system with them instead of as an annoying blister on their roadmap. Hooray! Yay, design systems. Can I get a woo? This is low energy right now. Woo! Thanks, y'all. This is really good. This is the cinnamon caramel nitro cold brew from Starbucks. It's very good. Highly recommend. Okay. So I'm going to give now some tips for atomic design component implementations. So the general theme of this, as I like go through a sketch of it, this is going to be a live code demo. I know we all love live code demos in a Wi-Fi-less room. It's going to be great. Is I'm going to try to start from the bottom and work my way up. Now we hear. Live code time. And if you want, not that I'm encouraging you to look at my code, go to github.com/JoshuaKGoldberg/design system sketch. This has the before and after files. Who's ready for me to live code? Woo! Yay! Thanks. All right. So on the left, we have the JSX. On the right, we have module CSS. Who here loves Tailwind? Who here hates Tailwind? Wow, all right. Every time it's a drastically different ratio. I don't care. You're all wrong. They're all terrible. So I'm using raw CSS, sort of with CSS modules, but it really doesn't matter. You can use Angular, React, Solid, Vue, CSS and JS, Tailwind, raw, whatever. It doesn't matter. You don't see my screen? Oh no, thank you for letting me know. How embarrassing. Now you see my screen? Yay. Now you still see my screen. Yay. Thank you. I love an audience member who speaks up. Thank you. That was very kind of you. To everyone else who didn't speak up, I'm sure you would have. All right. So I'm not going to show you any other code other than these two files. I'm just going to modify these. We're not going to see how to implement the design system. That's out of scope for this talk, as it is a beautiful, huge topic. But let's look at this code on its own. First thing that I see is colors. So I see there's a background, EEE, color 111, color 111. So immediately I'm going to, I forgot how I did these. So I'm just going to copy and paste from the solution here. And I'm going to make some CSS variables, because the first thing that I often do when I make a design system, is I'll create like a theme container, or you can like modify the root. I'm gonna put in some variables. Bar color. Is that me? My skin's shifting around like a snake. That's very unsettling. I don't like that. Okay, great. So we have already immediately made an improvement in the code base. It's not a very arguable improvement. Like one could look at this and go, you added like what, 10 lines of code, this is bad. But we have reused the colors. And now if someone were to say add in a dark mode, we'd be able to do that. Yay, dark mode. Woo. That's very unsettling. Okay. Next up, I see there are some reusable components. So you very rarely want to implement a header or footer in a specific page. So I'm just going to extract a constant, call this header or something like this. TypeScript doesn't know about JSX and its refactoring, and let's just pretend that I like moved this to a new file. Oh man, they're not giving me the move to new file option on TypeScript. There it is, move to new file, and that goes away. And then I'm also gonna extract a constant. By the way, did any of you know about this TypeScript stuff? I'm selecting the thing, extract a constant module scope, calling it footer, changing it to JSX, and then TypeScript also has an option to move to new file. That's pretty freaking cool. Yeah. This is also a dev tooling talk. Fun VS Code, fun fact. Cool. Now already we have a benefit here again because this page is much more simple to read. Previously it was a whole bunch of stuff. There was the header, there was the footer, it was a whole mess. Single responsibility principle dictates that a particular component, class, whatever, should generally have about one reason to change. So if you're changing all of your pages every time your header logo gets updated or whatever, that's a violation of SRP. Am I doing something wrong? You're just pointing. We're good? Okay, cool. I also forget what I did, and it's late in the day. So this is another change that I would recommend. I'm just going to go through them right now. What? What happened here? Oh no, all my code is missing. That's unfortunate. Did I? Oh man, I lost all my stuff. Anyway, so I would also recommend if you've got a main content area, which is what I call the component here, or generally the concept of this is your page, it's center aligned with a max width because it seems every website in the universe does that now. Create a main content component instead of having a div class name equals styles.main inside. It's just semantically easier to read. And then this one is controversial. Create a general text component. Not everyone does this. Some people use specific heading versus paragraph versus etc. But at the very least, I like creating a text component, and I'm going to zoom in now so you can really see it, with three things. Children, the content of the text component, an as prop, which is one of the most difficult things to model in TypeScript ever, fun fact, and a font size prop. And then you can also add in font weight, fonts decoration, or text decoration, and so on. And the reason why is the concept of an H1 or a paragraph or whatever should be separate from your concept of font sizing. A paragraph can be used to represent very big fonts or very small fonts. In terms of accessibility, the concept of a paragraph is not intrinsically linked to the font size. More of that in the other accessibility talks in this conference. So anyway, I'm just going to quickly undo everything here. On the left, we have the original code, and on the right, we have the new code. The new code has a lot more of this, I don't even know what to call the color, teal or green or something, but it's much more semantically readable because the new code just uses our pre-built design system components, making it much more reusable. And in fact, prettier is being annoying here, my auto formatter. So if I just go back to how one might format before, look at this. It's actually less code to do things with the design system. So hooray! We have built the same thing we were going to build before, but with less code. Yay! Woo! Thank you for humoring me. Let's get back to the slides. All right, enough live code. Play concurrent. Do you see me? Yes. All right. So I mentioned TypeScript. TypeScript good. Yes! Type safety is awesome. Read my book. So let's take a look at what goes wrong when you don't use TypeScript. This is... Does anyone want to guess what UI library or framework this is? You're all wrong. It's agnostic. It could be React or Preact or Solid or whatever. But without TypeScript, there's no way for this component on its own to say what that color prop is. There's no way to say that the color is allowed to be undefined or isn't, that it's allowed to be any hex value or particular sets of them. And we don't even know what the CSS prop does. Maybe it's some fancy thing where the color prop can be dark blue or something. So what TypeScript gives us, fun fact for those who haven't used it, if there are any of you left, because we really hate this approach, is it allows you to describe the types of things. Here we would describe that our submit button takes in an interface where the color is specifically whatever. Let's say these two hex values. Which means that we can then say, okay, no, the class name is not allowed. That's not a prop my button takes in. And dark blue is not allowed because it's not an allowed prop. This is a union of string literals. Fun fact for the terminology aware. So yay, this is good. TypeScript allows us to yell at people when they do stuff we don't like. But it also allows some kind of nicer things too. It allows documentation. Here in this slightly more complex component, we are creating a button that allows any of the attributes that is allowed on an HTML button element in React. So I guess this is specific to React, but it's similar in Solid and Preact. In addition to any of the attributes a button may receive as a prop, you're also allowing a variant prop, which is primary or secondary or outline. So if we pass in some random prop like color that's not a normal button thing, it gives us the red squiggly. Love the red squiggly. If it gives us, if we give it a variant equals wat or like something wacky unknown, it gives us a red squiggly because that's not allowed. That's not primary, secondary, outline. But if we give it variant equals primary, it's happy. Yay. And I'll show you another little cool TypeScript thing, one last one. I love this. This is why TypeScript to me feels like such a natural thing to bring up in the context of atomic design. This search form is what is the term for something that renders multiple atoms? What is that in atomic design? Someone? Molecule! Yay! Thank you. You sound like a second grade class being asked to recite the precedence in order. Thank you. It's great. So this molecule renders two atoms, and it takes in its props, button and input, which are then a description of take from those atoms props, specifically these properties. Button is allowed to receive whatever children and variants are for the button atom. This is really cool. So we are both verifying that people are going to give us the right components. If one of those things, let's say the variant, is required as a prop, then TypeScript will yell at us if we miss it. And we are documenting that this search form button thing, the prop, whatever that is, that's actually the button props. It's the same thing. And in your editor, you can right-click and go to definition, or as of this past year, I think, right-click, go to type definition on those. So, yes, good. We like this a lot. And then also, I just think it's cool to have a component that takes as props objects for things. It just feels really clean and nifty for me. I have figured out how to do this with less background noise, and it is unappealing. All right. Cool. Do I get one arm? Awesome. Oh, it's because this thing is moving. Nailed it. All right. Enough code. You're all entertained, so I'm going to talk about human-to-human interactions. That'll really cheer the room up. All right, passive knowledge sharing. There's passive knowledge sharing, and then there's active knowledge sharing. And I'm going to first talk to you about passive, stuff you do where you create it, and then other people use it, and there's no more work on your end. We like that a lot. Who likes writing documentation? I could have asked who here is awesome. Docs are good. So you got a design system. You have literally anything in code you want the rest of the team to use. How do you get them to use it? Well, in documentation for visual things, you have this awesome tool called Storybook. Does anyone here use Storybook or an equivalent? Awesome. So I don't need to explain to most of you that Storybook is something that generates awesome interactive docs directly from your components. This is a screenshot. I'm very, very in love with this website, gamut.codecademy.com. Codecademy's design system is called Gamut, still open source to this day. One of the things I did there helped do. And it has little interactive sections and like cool demonstrations of all the little components. So like if you wanted to say, look at a button, you would have this nice little playground where we'd say that, okay, CTA or call to action button is this thing. And then you can play with the props to make its size small or large or whatever. Can you imagine what it would be like if everything in programming was documented that well for you semi-automatically? Oh my gosh, this is awesome. You can not just see what the props for all your components are, but you can play with them? Oh, beautiful. I love it. So y'all were pretty excited about TypeScript and Storybook, right? Who here likes ESLint? Wow, I was not expecting such enthusiasm. Thank you, appreciate it. So linters in general are tools that look at your code, run a discrete set of rules, things like, oh, you should, never create a variable that's not used later or whatever, and then yell at you with anger if any of those rules are violated and optionally suggest ways to fix things. And there's actually a really good linter for CSS specifically that I want to bring up called stylint, because I mentioned earlier that you shouldn't hack internals, and stylint actually has a linter rule that generally much of the time will detect and yell at you for hacking internals. In your stylint RC, I still don't know what the R stands for in RC, but it's the stylint config file. You say the selector max type rule with 0, so don't allow nested weird things, where you don't allow non-class element type selectors. And then also there's a selector max universal rule. So the first one stops selectors that aren't classes. So you can't like select on a button that's a child of my page. And then also max universal stops the asterisk, because the asterisk is an evil in CSS, not quite at the level of bang important, but still kind of evil. So for a few examples, if this isn't making sense. So saying that any span in the universe should be color red is not allowed because you're affecting potentially things you shouldn't be touching. Your components might have a span. Who are you to say that they're color red? Wrong. But you could say like .custom, like my specific thing is color, whatever, orange. And then you can't do like custom star because what if that's a component? You can't do custom any span as a child, but you could do like .custom. So with this really surprisingly accurate level of granularity, we can yell at people to not hack internals in their editor before they even run the code and get it to PR review and then try to get it on a day that you're not there so you won't yell at them for things. Good. Passive. But not everything can be done with passive knowledge sharing. There's only so much documentation that you can write. And in fact, the more documentation you write, the less likely people are reading it. Am I right? So active knowledge sharing. Things where you interact with people, where if you make eye contact with someone, they're much more likely to agree with you. Sorry for the person I just stared at through the soul. So who here pairs regularly? Regularly, like multiple times a week, multiple times a day? I love you. Oh, okay, yeah. Pairings are awesome. A pairing is when you and one other person, maybe two, just hang out and code together. And it's an excellent way to share knowledge. The type of knowledge you share is almost always, in my experience, twofold. At the very extreme end of the spectrum in terms of experience divide, when it's someone who's very new to the things you're working on with someone who's very experienced, the very experienced person can very likely learn how to teach these specific things. What about these specific things are difficult or confusing or not well documented or just wrong for the newer person? And then, of course, the newer person can learn, knowledge from the experienced person. That's fine too. So pairings are great because both sides learn, and it's a great way to show off the right way of doing things. As a design systems engineer or web platform engineer, I was constantly pairing with people and then seeing they were not using TypeScript effectively, so I could show them ways to speed up their workflow, or they were hacking internals, and in this design systems world, we can save them, 20% time. Awesome. But there's a flaw with pairings. It's a one-on-one, or maybe one-on-two. You sometimes really want effective things. I'm not pairing right now. In fact, this is more of a presentation, but between the concept of a pairing, one-on-one or one-on-two, and a presentation, you still want to be able to work effectively with a lot of people. Has anyone here mob programmed before? A few? Anyone like literally carried a pitchfork in real life shouting? It's actually very emotionally cathartic. Would recommend. A mob or mob programming session is like a pair, but with a lot of people, which means you have, generally speaking, maybe one person who's at the very least guiding, at the very most actually leading, which means you have maybe 1 to 3 people actively coding at any moment, and the rest of the people are spectator sporting, or like in Gladiator, like shouting out instructions at the audience, which is great because you get to disseminate the same or a lot of the same information as pairing en masse. If we were all working on that refactor together, we would have all been experiencing it and all felt motivated to figure out what's going on. That's awesome. But 2 downsides of mobs. 1, who here just feels comfortable leading a mob of people at a computer? About as many hands as actually have mobs. So like, yeah, I would recommend pair for a while first, get used to that, and then try mobbing. Don't just leap into it. And 2 is that both pairings and mobs are not super repeatable. You can record the information, but it's not information that's made to be repeatedly viewed. It's like a one-time transient thing that might have lessons for later. So the thing we're doing now, the most passive with one little bit of active, is the presentation, where 1 or more people are standing up and talking. And this is really good for situations where you want the information to be repeatable, where you want to specifically craft a message that will last in perpetuity, or at least until you move to the next job. So you give technical and non-technical talks to your teammates. This is how we think in atomic design, suitable for engineers, developers, PMs, design, whatever. And then specifically, how do you use TypeScript, atomic design components, and JSX, etc. So that's a lot of great stuff, and I'm very excited about it. So let's wrap up. Some closing thoughts. 1, use atomic design or an equivalent. As long as you're using some way of organizing your components, I'm happy with you. So I highly recommend Brad Frost's general vibe. Also, the Atomic Design blog, and on top of that, the book are very good. atomicdesign.bradfrost.com. There are some good tech references. All the static analysis stuff I showed you is also available online. eslint.org, woo, Silent, and TypeScript. that's the end of the useful information. A couple more slides. I wrote a book, and I would love it if you all bought it because it's on TypeScript. And if you want to use TypeScript things good, I'm used to using two hands to explain this. This is difficult. But also, as I mentioned before, I'm a full-time open source developer. I maintain or work on open source projects. I don't have a full job. I'm independent. So if you want to sponsor me on GitHub to help me do that, that would be great. And lastly, I work on TypeScript ESLint, the tooling that lets you lint TypeScript code with a little yellow or some of the red squigglies in your editor. So if you want to help us out, that would be great. At the very least, get involved with the project. We'd love to have your feedback and input. Thanks, everyone, and thank you to the conference and AV teams for setting this up. This was awesome. Let's do Q&A. Woo! Who wants to yell at me? Who has thoughts? You. Love the question. Also, if I forget to restate the question for recording purposes, everyone yell at me. How complicated does a component, or generally how complicated would you expect a component to get before you should like split it up or turn it into other components or something? That's the, yeah, great question. Unfortunately, I don't have any like hard and fast rules. I have approximations for you. Put this thank you back on the screen. In general, single responsibility principle is one of the things I really like. There's no one principle that always works. So the concept of something should only have one real reason to change is generally applicable, but not always. But what SRP really means in atomic design, for me at least, is if I find that I am changing this component to satisfy different pages frequently, that if like the dashboard needs a new thing, so this component needs to change, and then the home page, and then I probably should change it. I also really like logical checks. Like if I have more than like 4 to 6, whatever, if statements, ternaries, etc. in a component, if I'm handling like what appears to be a growing exponentially number of cases, then that's kind of my line of thought. But yeah, that's the most precise answer I could feel comfortable giving, and I apologize if you wanted more. Cool. I saw you and then you. Oh, I love this. How do you distribute your design system to multiple code bases? There's a joke somewhere about just use mono repos or whatever, but that's not a good answer for everyone. But that is one answer. Sometimes a mono repo is really useful. It means you can develop your design system in the same code base as your main thing, which means you can send pull requests that modify both, which is really nice. Most companies I've seen that are more than 200 developers don't do that. Instead, they have multiple repos. At which point you probably are going to end up using something like packages, like npm or NuGet packages. And that's fine. That's what Codecademy does. That's what we did. The only problem with using packages, or like generally any sort of like two repositories, one ships an output which the other pulls in, whether it's packages or Git submodules, which is another option, is that then you have to send a PR to one thing to update it in the other, which means that you have to validate and get the first thing approved in the design system before the main repo. So what I recommend is have alpha versions or beta versions, or whatever you want to call them, published on every commit to every PR, or at least on every PR's last successful commit, so that if you have a piece of work that requires changes in one of your main repos or your main repo and the separate design systems repo, the pull request in the main repo can use the alpha package version from the design system repo. If you're using Git submodules, which I realize is much less common, the analogy is just using a different commit in your main repo. Is that what you were looking for? Cool. Mhm. Mhm. I love it. What a great question. I can tell you've done these things before. Excellent. So pardon me if let me know if I'm misrepresenting. In this example here, we've got like a theme. And actually what I would normally do is I would make this into like a theme component just for, reusability. I neglected to do that here. Ugh, the formatting. And then within the theme, well, first of all, there can be multiple themes. Like in Codecademy, there's a learner environment, or LE, learning environment, where there are like different colors and different things that are not seen elsewhere on the site. A lot of sites have like differing themes, not just light versus dark. And then also you have the dichotomy of approaches, or a lot of people use like just token values like FFCC00 for gold, or you use like color primary. Is that what you were asking about? Mhm. Yes. Cool. Semantic tokens versus literal tokens versus theme. Yes. I highly recommend using semantic tokens. I highly recommend if you want to customize, let's say, color, do something like color equals uh, primary, or like color, whatever, main content, background, color equals background. Because these semantic names, rather than like actual literals, are adjustable. They can be changed based on the theme. If you're in dark mode, what do you do? Do you say in every component that's background light normally? Okay, in dark mode it's background dark. No, you set it as the background color so that in dark mode it's changed to the background, which is what I was setting up for coincidentally in this theme.dark situation. Semantic tokens are also nice for readability because they explain semantically what it's supposed to be. And I think if you think of your components in terms of semantics rather than pixel pushing or specific rems or whatnot, then it's a much easier way to build things. Cool? Yay. You. Do I have any oh, sure. Apologies, I cut you off. I misheard. I'll also note that the lights are blinding me, so I can't tell if there were two hands or none in the. Okay, was one. Yeah, so the only experience I personally have with web components is that I wrote in a Chrome, or now browser extension that messes with GitHub pages. Excuse me, woo. And then I had to mess with GitHub's web components, and it was a pain in the butt, but I was able to do it, which says two things. One is that, oh, there's an advantage. It makes it harder for people to modify the components in annoying ways. Two, it doesn't stop them. Ha ha ha. So I, I, this is my impression of web components, but I can't give you a better answer. I apologize. My impression is that they're really new and really exciting, but like the technology is not as built up. Like the community ecosystem tooling is not as built up around them as it is for, say, like React or Angular. Um, I know that people are working on it. It's not like it's just dead out of the water, like we're never going to win. I don't know when it will be ready for like competing, so to speak, with like primary usage. But also, I'm sure there are people who would scream at me that no, it's ready and you're using it wrong. So I don't know. Cool. There is a person behind you, and then to your left, and then behind them. Never mind, just the person to the left. Blue shirt. Hello. Yeah, great question. I did not touch on this at all, but the question was around like grids, spacings, margin paddings, responsive units, stuff like that. Yeah, cool. Definitely part of the design system. Absolutely. One of the problems with design systems is that if I were to be comprehensive in my talk, we would be here tomorrow. Um, Highly recommend. In fact, let's look at what Codecademy does because they have their whole setup. So one of the reasons why I don't really like a lot of the I clicked Chrome and it opened PowerPoint. That seems odd to me. I don't like a lot of the offerings in there's no Wi-Fi in today's modern styling solutions. Is that it's hard to be type safe, but some design system builders such as Chakra allow you to be type safe in your responsive props, such that you can you can create components that take in JS props with names like ML for margin left, and then values that are like SM for small or whatnot, or even numbers that are specifically like 2 or 4 or 8 and so on. Anyone want to guess the password to Josh's Windows phone, the Wi-Fi hotspot? Ooh, close. Hotmail 60 is a good guess. It's Palm Pilot. Please don't pirate on my hotspot. Cool. So yeah, I highly recommend use things like where are the things? Like a layout grid in your design system. things where like you can specify like, okay, this is a grid with the default gaps and spacings and stuff, and then you can have props for like offsets or row heights. Where, and this is just a great demo of Storybook, where like you have a layout grid where the gap is 24, and that's like a specific one of several allow list properties that you can use. Like it would give a TypeScript complaint if you use 23. So yes, definitely valuable in the design system. My only warning is a lot of the times when you end up codifying like spacing, like people want to use them as margins and paddings, and then they get into this space where it's like really like 1.5 of one thing, and you get into these wacky combinations where people break out of the design system. That's normally a sign that you need to componentize something higher level. Or if people are doing weird combinations, you probably want to turn those combinations into componentized like atoms or molecules or organisms, most likely organisms. Does that answer like generally what you were looking for? Cool. Behind you. Awesome. Thank you. I'll repeat. If you want to use web components but don't want to use the base APIs, which now that you mentioned, I remember are like kind of very low level, then yeah, there are toolings and things around it. Oh shoot, what was the library? Stencil. Yeah. Svelte. Ooh. Okay. Got it. So Svelte has like a built-in tag thing you can use, and there's like a community thing for Angular. Cool. Does Reddit use lit? Does anyone remember this? I feel like I remember. Do you all work at Reddit? Oh my God. Okay, never mind. What other questions are there? Or elaborations on what I said, because I don't know everything. Despite what my wife says I say. Cool. Well, this was an absolute pleasure. Thank you so much for hanging out with me. I'm Joshua K. Goldberg on all the social medias, Blue Sky, Fostodon, Twitter, all those things. And feel free to chat with me on the Discord, on there, or just in real life. Bye.